Assalamualaikum. Today we want to present a case study using our own choice of topic, AAS, moving forward. And we are from this is our group, which is consists of 8 members. First of all is me, Muhammad Inia, Muhammad Anif, Nur Saira, Julia Akilah, Nur Izzati Najah. This is our table of content. Nur Ain Nabila, introduction, and lastly sample processing, sample preparation, analysis technique, data result and analysis, and lastly conclusion.
The environmental impact of industrial waste management, which is industrial waste management is challenging due to the disposal of waste into streams by advanced nations. This is uncontrolled dumping damage ecosystem, which polluting water and sediments and harming aquatic life. Industrial discharge contain toxic metals like lead, manganese, cadmium, and iron, which contaminate soil and water, posing significant health risks to humans and biota based on exposure levels and duration. The second one refers to the complexity and characterization of stream sediments. Stream sediments are complex mixtures of organic and inorganic compounds, which including corrode particles, organic matter, nutrients, and human-made particles. Their composition varies with climate, geology, and human activities, making characterization difficult. Understanding sediment structure and its physical and chemical properties is vital for studying geochemical dynamics and their ecological impact. The last point refers to the advantages and limitation of atomic absorption spectroscopy AAS. Atomic absorption spectroscopy AAS is a highly sensitive method for detecting metallic components in samples. It offers accurate measurements within 10 to 15 seconds and it can be automated. But AAS is costly, which requires
Next, the simple
specialized
processing.
infrastructure
Atomic
and
absorption
involves
spectrometry
time-consuming
AAS
sample
analysis
research.
every method in sediment by
Despite its
detecting
precision,
specific
the high cost and
element.
complexity
Here are the
limits
steps.
its use
Number
for routine
1.
laboratory
Sample
analysis.
preparation. Sample we are collect from 4 sites along the seaways river at a depth of 50 cm using a stainless steel spoon. Each 0.5 kg sample was stored in polypropylene containers and harmonious to ensure uniform composition. Sample we keep at 4 Celsius to prevent bacterial activity and maintain sample integrity. Number 2. Drying processing. The sample is first transferred to a clean, dry, and inert container to avoid contamination or reaction with the containers. This container should be properly labeled for information. The sample was then placed in an electric oven set at the consistent temperature of 40 Celsius. This gentle drying process helps remove any moisture content without change the composition of the sample. It is important to maintain a consistent temperature to avoid any thermal degradation of chemical change in the sample, ensuring accurate analytical result. Number 3. Ligation. Sediment sample are analyzed for composition and characteristics by eating to determine grain size and measuring nutrients, pH, conductivity, and contamination. AAS acid ligation. Using strong acid like nitric acid or aqueous reagent, dissolve metal and elements form the sediment sample. After cooling, the mixture is immediately concentrated nitric and hydrochloric acid to stabilize into element extraction and measurement. Exploited to around 0.2 until 4 ml. This prepared solution was fed into the AAS instrument. Calibration standard with no element concentration we are used to create a calibration curve, enabling the quantification of element in the sample by comparing their absorption to the standard. After that, data analysis. Absorption readings from the AAS instrument are converted to element concentrations using a calibration curve derived from a known standards. Results are reported as a part per million, ppm or milligram per kilogram, indicating the sediment sample element content. Last but not least, quality control. Quality control measure with analysis of blank sample and analysis of replicators we are performed to ensure the accuracy of the result. A blank method is used to account for any contamination introduced during sample handling and analysis. In conclusion, analysis of heavy metal in sediment using AAS requires critical steps: sample collection, homogenization, and drying before acid ligation. Through a calibration curve, the absorption is converted to a concentration report in ppm or mg per kg. Quality control such as duplicates and black are important to ensure reliable results, especially in the context of environmental assessment.
Reliable results. FAAS needs through digestion and oxidation, while ETAAS uses
Analysis
the
technique.
approach
AAS
with
is an
chemical
analytical technique
modifiers.
that calculates the concentration of specific elements in a sample by measuring the amount of light absorbed by atoms and ions which transition from the ground state to the excited state. The study focused on the determination of aurum, plumbum, nickel, and carbon monoxide in mineral raw material using AAS with a graphite furnace. The sample is dried, crushed, and sieved to produce a fine powder. Acids are applied to dissolve minerals and degrade the matrix. The acid mixture is heated to concentrate constituent and remove solvent. The method's efficacy is cross-checking reference material and electrothermal atomization results are similar.
In the assessment of corrosivity of gold induced by
Atomic
alkaline
absorption
layer
spectroscopy
using
AAS
AAS
is an effective
research
tool for
investigate the corrosion
quantifying the presence
behavior
of
of gold
elements
under
in
specific
various samples
conditions.
in the field of
The study sought
analytical
to
chemistry.
accurately
Research
quantify the
studies
risk of
demonstrate
gold
the
by
effectiveness of AAS in
utilizing
determining metal
alkaline
concentration in
monolayer
mineral
to
raw
induce
materials, evaluating
solution.
corrosively dissolved gold,
Based
and
on pure
assessing heavy
solution of the
metal
gold, the
pollutants in
outcome is
sediment.
the
A
polar
study by
solvents such
A.
as
Krzyzow showed that AAS with a
tetrahydrofuran
graphic furnace
dissociate
can
the gold more
accurately
than
measure metal
non-polar
concentration
substances
across a wide
such
range
as
without the
carbon
need for a sample metric
tetrachloride.
discharge.
AAS is useful for various applications, especially when combined with other instruments such as QSM, which was able to fill valuable insight into the corrosion-induced dissolution of gold and was able to show the metal's behavior in the presence of various alkylation monolayer substance. In summary, this investigation emphasized the importance of AAS in variety of scientific disciplines, including environmental monitoring and mineral analysis. AAS is a valuable instrument for researchers who are interested in
For
quantifying
last
and
one, conclusion.
comprehending the
Atomic
presence of
absorption
elements in
spectroscopy,
various matrix
AAS, is a pivotal in
to
analytical
this
chemistry and
realization.
environmental science due to its
Efficiently
precision
and
and versatility
versatility.
in qualifying a wide range of elements in a various sample types. Methodological advancements such as tailored sample preparation technique ensure reliable results by mitigating
Okay,
metric
thank you,
defect
Najla.
and changing
Now I want to
sensitivity.
present my
In
part
environmental
in the group,
application,
which is result
AAS
and data analysis.
identify and
My name
quantify
is Muhammad
heavy
Daniel
metal
Muhammad
pollutants,
Razi. My matrix
crucial
number
for
is
assessing environmental health
E2280237.
impact.
In the
Integrating with
assessment of
technologies like quartz crystal
corrosivity
microbalance
of gold
and rich
induced by
understanding of
actinium
chemical
monolayer
processes,
using
quality
AAS,
assurance
researchers
measure,
investigate
including
the
reference material
corrosion
and close
behavior of
validation,
gold under
ensure
specific conditions
credibility and
and was
readability
able
of
to
AAS
accurately
data,
quantify
supporting its role in
it
advanced
and
scientific knowledge of
observed that polar
environmental
solvents
management.
dissociate the
Thank
gold
you.
more than non-polar substance. The study used AAS and quartz crystal microbalance (QSM) for cross-checking results, providing valuable insight into the corrosion-induced dissolution of gold. AAS also proved useful in evaluating heavy metal contaminant in the sediment of the Sebaos River in Annaba, Algeria. The study effectively determined the level of metals such as ferrum, zinc, manganese, stannum, nickel, chromium, plumbum, cuprum using AAS with an acetylene flame. It revealed that heavy metal in the river exceeded the safe limit and their concentration were influenced by proximity to factories, agriculture, and liquid discharge. Factors such as pH and organic content greatly affected metal accumulation.